Imagine you have a fantastic student who aces every practice test you give them, every single time. They know all the answers perfectly. But then, on the actual exam, with slightly different questions, they struggle and fail. How can this be? This scenario perfectly illustrates overfitting in deep learning, and it is a significant problem because an overfit model has essentially memorized its training data, including all its quirks and noise, rather than truly learning the underlying patterns. This makes it perform exceptionally well on data it has already seen but poorly on any new and seen data, rendering it unreliable for real-world applications. The core reason deep learning models are prone to overfitting lies in their incredible complexity and flexibility. With potentially millions of parameters, these networks possess immense capacity to fit almost any function. While this power allows them to learn incredibly intricate relationships, it also means they can inadvertently learn to fit the random noise within the training data, rather than just the meaningful signals. It is like the student memorizing every specific word of the practice questions instead of understanding the concepts. The model achieves low bias on the training set by precisely capturing every detail, but this often leads to high variance and poor performance on new data. For practitioners, recognizing and addressing overfitting is a critical step in model development. One common way to detect it is by monitoring your model's performance on a separate validation dataset during training. If the training performance continues to improve while the validation performance starts to degrade, you are likely witnessing overfitting in action. Addressing this typically involves various regularization techniques. A key concept in this discussion is generalization error, which measures how well a model performs on unseen data. An overfit model will have a high generalization error. To combat this, techniques like dropout regularization are frequently employed. Dropout works by randomly omitting a certain percentage of neurons during each training step, forcing the network to learn more robust features that are not dependent on any single neuron or specific combination. Understanding why overfitting occurs is fundamental to building deep learning systems that are not just accurate on historical data, but genuinely intelligent and reliable in the dynamic real world. It transforms your model from a mere memorization machine into a true learner, capable of adapting and making accurate predictions on novel information, delivering true value.